the way things are nowadays with education, you guys don't get enough of a chance to play with numbers. So what I mean is something like if I had to factor, let's see if I can make something up. I can make all kinds of shit up. X squared. What do you got, Jeff? Yeah. Yeah, that's nice, isn't it? So, just to really, one level I really want everybody to let me know if you don't understand this. We've done enough foiling problems to realize that that form could have come from a binomial times a binomial. Right? Because we've done stuff like x minus 4, x plus 6, and we multiply that out, and we get a 3-term dealio, right? Okay, so that's where we start. We know this should have come, if it's factorable, which I don't know yet, it should be able to be written like this. Is everybody cool with just that idea? Because that is a hidden kind of assumption that maybe sometimes I make. Everybody kind of sees that. But that's why I can go there. What has to be here and here? Yeah, because that's x squared. And the foiling process, it would have come from this times this. So it's got to be x and x. So then this problem becomes a playing with numbers problem. Right? And by doing enough of these type of problems, I know where that would have come from. I know where that would have come from. Right? In this case, when I did this, I got x squared plus 6x minus 4x, which gave me 2x. Is that cool? Minus 24. Is that all right? So where'd the 24 come from? This times this. Where'd the 2 come from? This plus this. And every time I do that, I could go back and see, holy shit, that's every time. It works that way. So we develop a process for going backwards. We say, if I could find factors of negative 480, all right, what's kind of crappy about that number? It's huge, it's big, it's huge. But more importantly, there are large numbers that have very few ways to factor them. 480, there's a shit ton of ways to factor that, right? Just to use a technical measurement. So, again, you're not going to hear a lot of teachers that, for some reason, I don't know why they don't agree with me. It's easier to make numbers that do that first, and then check to see if they do. I just need them to, at the end, do both. Who cares what they do first? So what can you tell me about the two numbers, since this has to multiply to be negative? They have to be different signs, which means they actually subtract to be 4. If two things are different signs, and I combine them, what's negative 6 plus 4?
2.
Negative 2. That's 6 minus 4. They are, in a sense, subtracting when they're opposite signs. How are we doing so far? So again, there's all the layers to this kind of problem hinges on how good you are with numerical stuff like that. Just realizations like that. So instead of finding all these things, let me find things that add to be negative 4. So something silly like negative 10 and 6, they add to be negative 4, right? But what do they multiply to be?
6.
All right, that's no good. All right, we got to be a lot bigger than that. So maybe I take a huge step up. Negative 20 and what makes negative 4? 16. And what's twice 16? 32. So what's 20 times 16? 320. Yes? Yeah, you just add 2 times 16, add a 0. Right? So they multiply to be 320. Still not big enough. But do you see how that process is leading you to the answer if you let it? Just follow it. Not big enough. Make it bigger. Okay, I can do that shit. So eventually, what do you guys want to guess here?
24, 24.
Yeah. Because there are other things. See how that ends in a 0? That's a clue too. I don't want to make it feel like I'm dumping a lot of shit on you to worry about, but if you see what it multiplies to be at the end, you can kind of make sure that the numbers you pick do that, right? So I wouldn't pick 22 and 18, because I wouldn't have 0 at the end. You see what I'm saying? There's a little things. They're not things to memorize. They're just things that are trying to help you. And sure enough, 24 times 20, right? Twice 24 is 48. Add a 0. Kick ass. So what does that mean the answer is? You take all this extra shit away.
X minus 24.
Yeah, x minus 24, x plus 20. So what we did is we noticed a pattern to help us zoom in on what's important. The numbers are what's important, because we got everything else. We got the form of it, we got the x's, I just need the numbers. Right? Okay, I like it. So that's those kind of problems. Coming back to GCF, because that's one that I think I make assumptions about, and I know my colleagues do too. I always assume that GCF is not too terrible, but it could be confusing sometimes. So let me see. I'm going to write it a way that I don't really love writing, but maybe this is going to make more sense to somebody. So you see how this is 5 times x times x times y, right? And what's this? 5 times 4 times x times y, right? Can you see what they both have? And I could have made this 5 times 2 times 2, but you see how that, I can introduce one little shortcut. If that shows up, then you don't have to worry about breaking the rest of it down. So what do they both have? They both have a 5. They both have an x, and they both have a y. So what's extra in this first guy besides what I just did? An x? And what's extra in the next guy? 4. So I could take out a 5xy, because that's what they both have. Somebody distributed it across and gave it to them. I'm going to come around the corner and take it right back. Give me that. Looks nice. And so what's left in this first term? X. And what's left in the next term? So if you want to do it this way, there's nothing wrong with that. I just don't, I want to get you past that quickly, because if you get stuck in doing it this way all the time, you're never going to progress very far, because maybe. But this is something you could do if you're having trouble with that. That's the idea. What parts do they both have that I could take back out? Because how would I check this? Yeah, I would multiply it back in, which means give that back to both. Which is why going backwards is take the same thing away from both. They're exact opposites then, right? Distribution is giving them both the same thing. Undistribution, the GCF is taking that same thing back away from both. Okay, maybe. Okay. And of course that leads us to grouping. The bonus problem I really liked. It was actually a grouping problem. I know, I thought maybe. Not you specifically, but actually people. No, actually you specifically.
Oh, dang.
So if I had a problem like this, let me see. Let's see if I did this right. Why does it say, that's fine. Okay, oh. So I'm almost, that was past me. It's not me. How many terms are there?
A lot.
6. 4 or more terms means grouping. And what I try first, now to be honest, there's more ways to group than this, but right now I try to group them into pairs, yeah. And then I hope that whatever I do leaves something that's the same in everything. So a normal grouping problem would be just take one of these things away. That's what we're used to, 4 terms. But I just want to show you, it's not really harder if I put more shit down. What comes out of here? Oh, sorry.
What if there was an odd number of terms?
Oh, all right. We'll do one like that.
Oh, no, dang.
We will. Well, you asked. What comes out of these two? X. What's left? Minus 4. And what comes out of these two? A. And then what comes out of these two?
2x's.
X squared,
Why?
y, x minus 4.
Jeff, I'm noticing something.
Good. Noticing you're writing on the board, Jeff. Great. So what are they? Now how many terms are there? Just by doing that, I've decreased the number of terms. You guys see that?
3.
There's 3 terms now. What do they each have?
X minus 5.
Yeah. Let me ask you this question. Do you see a 4 up there anywhere?
No.
Nope, good. I love it. You guys are all like, that's what he told me to say. I personally am not insane. This insane man wants me to say that. I don't see a 4 in this anywhere. I see an x minus 4, an a, and an x squared y. That's what I see. All right. So what comes out?
X minus 4.
And then what's left? X plus a
Plus x squared y.
It's like a
Okay, I love
cult.
it. All right. So this idea of the process doesn't care what's in it, how long it is, whatever. The process just says, do it. I got 6 things, so I got 3 pairs of things. I do the same stuff to it. Now, in real life, a good question would be, man, you just put like a squared here and the whole thing goes to shit. Like, exactly. But we first learn the things that happen ideally, and then we start to learn tweaks to those things. But I couldn't do the tweaks unless I learned the first thing, unless I learned the base level. And there's a whole ton of math where this kind of thing naturally happens, if we don't mess it up. Where it is factorable just because of the physical things behind it, what the math is trying to model. Very often will lead to stuff that I can do this kind of thing with. Okay, maybe. And let me give you a little bit of motivation for this. I'm all about that motivation. Look at this problem. This is in our future, but I'm going to bring it from the future right here.
Wow.
Everyone will have this problem.
Whatever.
We'll have this problem.
What do you got, Jim? Yeah, sure.
Mm. You can stop there.
Yeah, let's do, yeah. Look at that shit. You want to do long division on that? No, let's not do that.
Extra credit.
Watch this. I want to show you where this is leading us. If I had a problem like this, how would I do this? How would I reduce this? Yeah, so I can rewrite 18 as what, for example?
6?
3 times 6?
Yeah.
Okay. And then 48 would be 8 times 6, right? And then I can see what cancels, right? And why exactly do the 6's cancel? This is a very strange question, but why am I allowed to cancel those 6's? Because division is the opposite of,
Multiplication.
yeah. So what do I do over there? Same freaking thing, right? How do I factor the top? Factors of 8 that have to be 2,
4 and 2?
4 and
right? Is that cool?
2. Yeah.
And then the bottom. Yeah. Had to be 9, multiplied by 20, be 4 and 5, and then what do you see can die? Die.
And then 2 fifths.
Do you see what I'm saying? Right?
To be 2.
I couldn't do that if I didn't know how to factor. And this kind of thing also naturally happens. Or if it doesn't quite fit, I can tweak the process I just did to kind of work in that situation. So again, a lot of mathematics is, here's the ideal. Here's this. Oh shit, okay, what's going to bridge that? I can tweak it a little bit. Okay, great. Now here's a weird thing. Let me tweak what I just tweaked. All right, great. Still have to tweak. That's what math people are, just a bunch of tweakers. I say. All right. But actually, it's funny. I've never said that. And it actually, it's true. We lay some groundwork and then we tweak the shit out of it. It just sounds wrong. All right. So let's come back to the last thing we were talking about. That thing that everybody loves so much, the surefire method. So this is kind of like, this is difficult because it has everything we've done so far in it at once. So let me make a problem that will hopefully work. All right, that'll work. Okay. I want you to realize something. The reason I don't immediately do this, and this is actually a valid method. This is called the trial and error method. In the name, you should see why Jeff doesn't really like it that much when you're first learning this stuff. And to be honest, maybe I'll get us to a point where I can show you what I actually do if I was going to try to factor this. All right. Weird shit. Someone called it the Texas slide, believe it or not. It's not a country line dance. The reason I obviously can't do this anymore. But do you know if it's 5 and 2? It could be 10 and 1. Right? And then 5, is it 1 and 5 or 5 and 1? Is it positive 5 or negative 5? And is this 5 and 2 or is this 10 and 1 or is 10 supposed to be there? So I am a little bit building that up out of proportion. But the less you're cool with numbers, the harder that kind of combinations thing is. Now, some of you guys might have learned trial and error method. And if you're pretty good at it, okay, but I need to see some kind of idea of what the hell you're doing. So if you do trial and error method, I want to see maybe a few failed attempts. Some idea of what you're thinking. Otherwise, that ain't no work, and that ain't no good. Just to show off my grammatical skill in this. All right, go ahead. So the best way to do this, the most detailed kind of recipe-ish way to do this, is to do what first?
Greatest common factor.
That's right. See if there's a GCF. Is there a GCF? No.
No.
Right. Because sometimes, if you can take a 10 out, this ain't no problem. But since that 10 doesn't want to go anywhere, I have to take it into account. So like you guys said, I think. So I'm working with what?
Negative 50.
I really want you guys to realize I'm about to, so I just can't work with that. I have to work with that times that, and then I do the same thing. Two numbers that multiply that, and add to be the middle. And maybe that's something you guys can see. Not that many ways to do 50. 25 and 2. Right? As long as which one is what? Yes, 25 is negative, so that it comes out negative. And then how do I use that? Now some people will do this. Why is this obviously wrong?
Because you don't have 10x squared.
Yeah, x times x is 10x squared. That's neat. So that you can't, you know if there's not a 1 out front, it's going to be more difficult. It's going to be a few more steps. That should just be, that should make sense. There's more complicated parts to this thing. You can't just jump to it like that. If the first one was a 1, that would have worked, right? All right, so what I do instead is, what do I do?
Rewrite it.
Rewrite it. How?
Minus.
Yeah, so I would put the
25x
minus first,
Plus 2x minus 5.
and then we get a little reminder of that thing I showed you yesterday. Yeah, let's get there. What comes out of these two?
5.
X
5x.
and 5. Cool.
That's x minus.
2,
Oh, dang.
x minus
5.
5. And what comes out of these?
1.
1. There you go. So plus 1 times this. So that's what you do when you have a grouping problem and it looks like, well, there's nothing that can come out of that. But you can see these are the same. All right, we'll just put a 1 there so it looks more like what I'm used to. I don't really have to do this. If you really care, we could do it. But now it looks more like what I'm used to. So what's the answer going to be?
5x plus 1 times 2x
Okay.
minus 5.
Or vice versa, right?
No, only that way.
Yes. No.
Dang.
I was gonna say it's same, All right. So again, you have got to help me, if you're having trouble with the numbers. Okay, so if you do like, here's one little thing, 50 is not that interesting of a number, but if all you can think is 5 times 10, 10 is 2 times 5, and then you can rearrange those. 5 times 5 is 25 times 2 then, right? I mean, so you can do that with bigger numbers. You can factor it the way you think, and then you can factor it further and recombine those. And it comes up with other ways to factor that you might never have thought of. Or take the calculator, take the number you're working with, divide it by 2, divide it by 3, divide it by 4, and then just until you get the right one that adds up correctly. That's the most basic way you could do that, right?
That's for geniuses.
But I'm wanting to get you guys to maybe feel a little motivation to try to make some connections with numbers that maybe you've never had to before. Because now it's sort of like a survival thing. I got to make some connections so I can make this thing go faster, right? Okay. So here, you guys try this one. See if I can make one that works. Wouldn't that be nice? Let's see. Start it off. There you go, buddy. Going down. Ooh, that's gross. That's not too bad. That's fine.
I should have did it.
Okay, that'll work. Wait, do this. Make that plus.
Oh.
What? What do you want? Yeah, that'll work. I like that one a lot.
It's negative 27 and negative 2.
All right.
You like Caesar a lot. Scheiße. Let me help you out. If you're not sure, first step, what did you guys do first?
Found the thing that does the 2 to the right.
Notice that there was no GCF. That's right.
Oh, yeah.
What did you do next?
Multiply 6 and 9.
Yeah, the fact that that's not a 1, it's 3 terms. You know you do 6 times 9. What's 6 times 9?
54.
Craziness. So again, I have that sheet, and I always want you to understand the reasoning behind why we do what we do. And that's why I created that sheet that had multiplying stuff out, noticing patterns, and then using that pattern. Right? If you're like, I don't care about that, okay, well, start to notice. I'll get past it. It's 3 terms. 3 terms means if that's a 1, kick ass. It's just making the numbers work. If that's not a 1, okay, shit. I have to take it into account. And then what do I do at 54?
Divided by 2.
Well, cut it somehow so that, yeah, you could try to divide by 2 and it happens to work, right? That was the point, my suggestion a minute ago. 54 divided by 2 is,
27.
and if they are both,
Negative.
then they'll make
Positive.
No. Don't make negative 29.
Well, if you multiply them.
I'm with you. That was in the past. Alright,
This
stop.
is a new day.
You guys get that?
Mm-hmm.
So, you are here today. This is good. If you're somebody who's not getting something up here, you are not alone. You can ask questions. What do I do with that information now?
How do you rewrite it?
They're both negative, right?
Mm-hmm.
So I gotta get, so it doesn't even matter. Which way do you guys want to write it? What do you want to put next?
I want to put the
27.
27 there.
2.
22.
Pick number 3, my lord.
Alright, I'm gonna put the 2 there.
Darn it.
27 by the 9.
Then.
Oh, that's a great idea. I should have done that.
Yeah. Because then you don't get that weird thing about there's nothing to come out, but you can take a negative 1 out, it would still work, but when they're both negative, there's no real preference. If one is negative, one's positive, you put the positive one there, so you don't make so many negative mistakes. And again, it really doesn't matter. We should get the same answer at the end if we all do it right. What comes out of here? 2. X.
X.
3.
3x minus.
X.
You took a 2 and you took an x.
1.
1.
Oh, yeah.
You divided out everything. Left the
Oh,
poor
yeah,
guy
X is,
with
yeah.
1. I know there's got to be a 3x that shows up in here. What do I take out of this to make it become positive 3x?
Negative 9.
Negative 9. See how I have to change the sign?
Yeah, negative.
So again, I know there's a lot coming at you, but the first guy is a clue for the next guy. I know I need a 3x here, so that tells me I got to take a negative 9 out. Negative divided by negative is positive 3x. 9 divided by negative 9 is, and thank God now they match up. So the most common mistake right here is to put that, because you forgot you took a negative 9 out, and then somehow they keep going. Right? But right there you know you can't go further, right?
Yeah.
Because if this is the same, that is the reason I can go further. So if they're not the same, I can't go further. So what do I do next?
That's 2x.
Sure, you can do it either way. 3x minus 1 times 2x minus 9, or the other way around.
Yeah.
And how do you check that?
Just multiply it out.
Multiply back out, make sure you get that. Yeah.
Can you take out a negative 2 equate to the 6x squared minus 2x?
The reason you don't really want to is you don't normally want this first piece to be negative. But then I see what you're saying, because then you could take a positive 9 out of there, right? All right. So let me just show you what that would look like. And you're like, I don't need to show me. I did it on my paper, but for everybody. So if I took a negative 2x out, and this is nothing I'm suggesting, so don't even write this down. But I do want to show you, you're right in a sense. You get negative 3x plus 1, and then if I take a 9 out, I get negative 3x plus 1. But do you see why math people don't like that? And some of you guys, let me see if you guys realize, those are the same answer, by the way. That is the same as that. Because what could I could take a negative 1 out of him and a negative 1 out of him, and the negative ones would kill each other, and then it would be the same as that. But which one looks better?
That one.
Yeah, this one. And again, it's not an aesthetic thing. It's not anything you should feel bad about. It's just we don't like things starting off with a negative sign if we can avoid it. But and again, right? If you want to write like this, I really can't complain. I mean, but again, we like to write things in descending order. But I wouldn't take points off if you did this. It just makes it a little bit easier to make a negative mistake when you do that. All right, I like it. So. I want to talk about some new stuff for a little bit. And next time, I'm going to bring, so we're about to talk about what do you do when there's two terms. We've talked about 4 or more grouping. We've talked about 3, surefire or the easier thing when there's a 1. And now we're gonna talk about two terms. What do you do? Kind of makes sense. I sort of talked about this earlier. Remember we did something like this? And it said the middle term really is 0, right?
Yeah.
So what are two numbers that multiply to be negative 81, add to be nothing?
9 and negative.
Yeah, they have to be additive inverses, just to bring back some awesome terminology. Same number, different signs. That's all additive inverse means. So x and x makes x squared, 9 and 9 makes 81, minus plus does two things. They multiply to be negative 81, and they add to be 0.
Zero.
So what's wrong with trying to do this?
It's because it's positive.
It's positive, so you no longer can have opposite signs. So whatever the hell you write down you think is the answer, it can't be because the middles won't cancel anymore. You can factor a difference of squares. And the reason you can do this is the same reason you can't factor a sum of squares, at least not using real numbers. Oh yeah, alright, so that's later. So right now, using everything we know, we can't factor this. I'll just say that. Alright? Because if you think it's this, you're wrong. Because you get 9x, 9x, 18x. There's no 18x, that can't be the answer. And minus minus, you have negative 18x. Okay. There's a shorter way to think about this. Do you see how x squared xx, 8199, plus minus? So whenever I have a problem, and it's got two terms, so here's another one. You can do it, Jeff. What's another? Just put it, there you go. Two terms there, right?
Mm-hmm.
There's minus in the middle. Is everything, can I cut everything in there in half multiplicatively?
No.
Do you see how I cut 81 in half?
Yeah.
Multiplicatively, 9, 9. What part of this can I not cut in half? Who said they can't do it? What's 9? 3, 3. What's y squared?
Y.
Y. What's 25?
5.
5, 5. What's W6?
W.
W3, W3. Doesn't that make 6 W's?
Yeah.
So as long as the numbers are squares and the exponents are even, I can cut everybody in half, right? Now stay with me. So we're basically applying the same idea. I built this looking at it like one of these problems with a 0 in the middle. But now I'm going to make it even better for like, look at this disgusting thing. Again, nothing wrong. 9y squared is 3y, 3y. 25w6 is 5w cubed, 5w cubed. And then I have to put a,
Plus.
sure, plus,
Minus.
minus. You got a 5 over there.
Plus an S.
That's a difference in squares. So if you identify, you say it's got two terms, minus, I can cut everything in half,